Hello, this is video number 20 using the onboard accelerometer. Alright, so this is basically the program working. So what it does is it knows the onboard accelerometer. There's an X coordinate, a Y coordinate, and a Z coordinate. And it takes that and it knows which direction it's being tilted towards. So we also have four LEDs for the different directions. And if it's tilted either to the left or tilted this way, then it will go forward, and then the other two directions, the motor will go in reverse. So, and also the piezo plays a frequency. So we tilt it this way, the motor's going forward, the piezo is playing a frequency, and the green light is on. We tilt it this way, the yellow LED's on, and still going forward. Then if we tilt it this way, we have the blue LED and the motor's going backwards, and then we tilt it this way, the red LED's on and it is going in reverse, and the piezo is still playing a frequency. Alright, so here is our board layout. So what we got here, we have the motor driver, and what we have on that is this red wire. The first one is going to be the signal that controls the motor speed. This orange wire is the signal that controls the motor speed, which is connected to 5 volts, which goes all the way through to 5 volts over here. Then the red wire actually is the direction pin for 2 for the motor, and the brown wire, the next one here, is the direction pin 1 for the motor. And then if we go down a bit further, this red wire is a direction pin 2 for the motor, and then the black wire controls the speed of the motor, and then the last brown one down here is going to be ground, which is going to ground, which leads up to this side, and then this black cord leads to ground. Then going to the other side of the motor driver, first here we have the green cord under here, which is ground, which is this side of the board over here. Then we have the orange wire and our purple wire are the motor B connections, and then this next orange wire and this red wire are the motor A connections. As well, we have 100 ohm resistors for the LEDs so that they don't burn out. So we have one here, 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 and here, as well as our 4 LEDs. And for the motor, we use 5 volts, but for this side of the board, we use 3.3 volts. As well, right here, we have our piezo buzzer, which is connected to ground, and it's also connected to the 9 digital output pin. Alright, so here is the code. Up here, we set all of our pins. And then down here we set all of them as outputs. We also start the accelerometer, and we set the range to 2 G's. Then we make integers so we can read the absolute values of the accelerometer, so we can determine which way it's tilting. If this if z is greater than 0, so basically if the orientation is just lying just by itself and it's not tilted to the side, then we're going to print on the serial print all of these are off, and we're also going to use the brake function, which just makes it the motor stop. The motor's not going to move. We also have an else if, so if it's not braking, if it's not still, and if it's tilted, then if it's tilted to the left, then we are going to do the forward function. The green LED will be on, and we'll also play a tone of 600 frequency, and I just put 100 as the delay. It's only 1/10 of a second, but the code just keeps running over and over, so if it stays tilted, the piezo will just keep going off over and over again. So the sound won't overlap, and it'll still produce a nice sound. We have the reverse function, which is the else. So if it's not tilted to the left, then it would be tilted forward. We put reverse, then the blue one comes on. Then we also set tone for that. All the tones are the same, because it's not really anything special. It's just the direction. So I just put a tone on just to make sure that it's another thing for troubleshooting too. If something's not working and the tone's working, then there's something wrong with your circuitry. We also have the other directions too. It's the same exact thing except the different color LED will turn on, and then at the end we turn off all the LEDs so that when this runs through again, we won't have any LEDs still staying on. So because it's impossible to have two on at a time in this code, because it's either one of the 4 directions. Here are all the methods for the forward, reverse, and brake. You can see I put serial print forward in the methods. It's just saving time. Just like I could have put these tone functions, I could have easily put them in the methods. It would have done the same thing. The method is just a way to clean up your code and make it a little smaller, so you don't have to have redundant lines. We also here have our serial monitor. So what I did was I printed. It prints whatever it's going forward, stop, reverse, and also which LED is on. So currently all LEDs are off and such, as seen. Everything's off. It's stationary. If we turn to the left, forward, green LED. That's gonna be the green one. We go to yellow. Yellow forward. Got the yellow. Then we go to blue, tilt the other side, blue, and then the last one, red. That's it. Thanks for watching.